Hello, my dear students of class 10 DIV. I am going to the next lectures in your physics, CBSE Physics Class 10, Chapter 10. I hope you are all well. Now, at first we know the images, ray diagram for images, how images are formed in different positions of an object, right? Images of an object by the reflection or image of an object due to various positions by a concave mirror. Images of an object due to various positions of it by a concave mirror, by the reflection of a concave mirror. Now, at first we know for ray diagram, at least two reflected rays are required. One, remember this, one, it is a concave mirror, and its pole is at P and its center of curvature at C. We join CP and extend it on both sides, give the principal axis. This is the principal axis. This is the focus, principal focus F. Remember that if a ray of light is incident on the concave mirror, here M1, M2, parallel to the principal axis, any ray, right, parallel to the principal axis, then after reflection from the reflecting surface of the mirror, it passes through the principal focus. Right? It passes through the principal focus. If a ray of light coming from the center of curvature and it is incident on the surface of the reflecting surface of the concave mirror, then it is normal at the incident point. That is, we write O, A, B, D. That is at the point D. Since at the point D, CD is perpendicular, so it comes back. That is, it reverses its direction. Now, if a ray of light is incident at the pole, P, CP is also perpendicular to the principal axis, because CP is the radius. Now, hence, if another ray of light, here we write CD, here we write EF, ET, EEP, then it reflected by obeying the laws of reflection of light. That is, the incident ray, the angle of incidence is equal to the angle of reflection. And if a ray of light coming from the principal focus and incident on the concave mirror, then after reflection its direction will be just reverse, that is parallel to the principal axis. Parallel to the principal axis. Now, at least two reflected rays must be required to draw a ray diagram. At first you see that for various positions of the object from the lens we have some situations, right? Number one, object at infinity, that is object situated at infinite distance from the concave mirror. Object at infinity, that is r equal distance equal to infinity. Now we see what will be the ray, what will be the images formed by it, right? This is a concave mirror. This is a concave mirror. Bulging portion, that is outside portion, is silvered, so that the inner portion, that is at the center of curvature portion, will be reflecting surface. This is pole. We draw it. It is pole P. This is center of curvature C, and we join CP. It is the just midpoint F and extended on both sides, which will give us the principal axis, x prime and x. Let us consider an object is situated at infinity. We may consider the rays of light coming from infinity as a parallel beam of light rays, that is, they are parallel, but they may or may not be parallel to the principal axis. If not parallel to the principal axis, then they, after reflection, they meet at a point on the focal plane, which is the secondary focus, which is changeable according to the obliquity, that is angle made by the light rays with the principal axis. We draw the ray diagram, and what will happen we see. This is an object, infinite distance object রয়েছে, infinite distance infinite, object is situated at distance infinite rays will be parallel to each other, right? We take these parallel rays, we draw it in another color, right? Only 3 or 4 rays are shown here. All are parallel to each other, coming from infinite distance, that is infinity. Hence, after reflection, they meet at a point on the focal plane. What do you mean by focal plane? Focal plane is an imaginary plane perpendicular to the principal axis and passing through the focus. That is, it is a focal plane. It is a focal plane. Remember it, just imagine it. It is a focal plane. This is the focal plane. Focal plane. Now, it is situated, the light rays which coming from pole, this angle must be equal to this angle, and all rays passing through that point on the focal plane, which is called the secondary focus. Now, this is another point, this is another point. Point are same, f dashed, point are same. Next, here you see the ray diagrams with an arrow. For clarity, we draw here also some arrows, right? Hence, the image will be at the secondary focus. This is the secondary focus, secondary focus, secondary focus. Formed at the secondary focus. Hence, what is the position of the image formed by the concave mirror when the object is at infinity? It is obtained at the secondary focus on the focal plane, and it is obviously very point like. Its magnification is nothing, that is, it is diminished. Magnification is very highly diminished, and the image is real, Now, this is the so we write this. Number 1, the image is formed at the secondary focus, image is secondary focus on the focal plane, obviously on the focal plane. Number 1, it is formed at the secondary focus on the focal plane. Image is real. The image is real. That is, the reflected ray actually meet at point f dash, that is the secondary focus on the focal plane. The image is real. Here, if the image is somewhat large, then it will be inverted, but here, since point light and it is point light, highly diminished, point light, that is highly diminished. Hence, we have, when an object is situated at infinity, then the image formed by a concave mirror is obtained at the secondary focus on the focal plane, and it is real and highly diminished, that is point light. Now, second point, object is behind the center of curvature, far behind the center of curvature. Object number 2, object is behind the center of curvature. What will be the image? Its position, nature, and magnification. Right? We draw a concave mirror. we draw a concave mirror. This is the pole of the mirror. This is C, that is center of curvature, and at the midpoint of CP, this is focal point, principal focus, and this is that is, if we join CP, C and P, by joining C and P, we have X prime as the principal axis. Now, the object is linear object. We take linear object. This is a linear object situated behind the center of curvature, that is here. It is the object OP, right? For clarity, we draw the figure OP. Now, a light ray coming from the top point of the object OP parallel to the principal axis, and then it is incident at A. After reflection, it must passes through the focus according to the rule, according to the experimental investigation. This is the OA, right? We write it in another color so that it will be prominent. It will be prominent. The light ray from the top of the object OP situated on the principal axis vertically. On the principal axis vertically, it passes through the focus. It passes through the focus. And one ray we take through the focus. Then, after reflection from the concave mirror, it will be parallel to the principal axis. It will be parallel to the principal axis. Hence, these two reflected rays meet at a point O dashed. At point O dashed, or another ray must should be taken if required. Not required here. Then we show this also, that is, if a ray of light is passed through the center of curvature, it comes back. That is because it falls perpendicular. Hence it come back. That is, it retraces its path after reflection. This is the point O dash, where the rays, here we take three rays from O after reflection meet or coincided. Now, if we draw a perpendicular on the principal axis from O dash, that is this, then O dash P dash O dash will be the image formed by the concave mirror of an object situated just behind the center of curvature. Its position is between C and F, that is between center of curvature and focus. You write it between center of curvature and focus. The image is formed between the center of curvature and focus of the concave mirror. The image is real and inverted. And not highly diminished, but it is not highly magnified. It is actually diminished but not highly diminished. That is, magnification is in this case the magnification will be such that the size of the object and size of the image, if we compare them, size of the image is less than that of the object. Right, these 3 points are written in your exercise book. 1 point, if an object is situated behind the center of curvature, then after reflection by the concave mirror, by the reflecting surface of the concave mirror, it will be obtained between the center of curvature and focus of the concave mirror, and it is real and inverted. Must write real and inverted, that is real and upside down, real and inverted, or real and upside down, and the image magnification of the image is small, that is diminished image will be formed. Right, these 3 points must be right in your exercise book. Now, object is at C, that is center of curvature. Object is at C. What will happen? Object is at C, that is center of curvature. Object is at the center of curvature, at the center of curvature. What will happen? We see object is at the center of curvature. What will happen? This is the mirror, concave mirror. This is the pole of the mirror, mirror M1, M2. This is C, and if this is F, that midpoint of CP. We prove it later that the radius of curvature R is equal to 2 into focal length of the concave mirror. This is principal axis, x prime x. Here the object is situated at C, that is center of curvature, at C. Write OC. Now, a light ray, we take 2 light rays only. A light ray is incident on the concave mirror parallel to the principal axis. Parallel to the principal axis. Then after reflection from the mirror, it passes through the focus. It passes through the focus. Another ray of light coming from O, which is passed through focus, after reflection it becomes parallel to the principal axis. These 2 reflected rays meet at O dash. Hence, O dash C will be the image formed by the mirror when the object is at the center of curvature. Here you see that the object is obtained, object is formed at the center of curvature. Object is formed at the center of curvature. Object is formed at the center of curvature. It is real. It is real and the same size as the object. That is magnification 1. That is the same size of the object. Write notes in your exercise book. In this case, that when the object is at the center of curvature, that is when the object is situated at the center of curvature, then the image formed by a concave mirror due to reflection of by a concave mirror will be obtained at the center of curvature, just below the principal axis, and it is real and the same size as the object. Write it in your notebook. That is magnification becomes 1. Now we see what will happen if the object is in between C and F, that is center of curvature and focus. Object is placed when object is placed between center of curvature and principal focus. What will happen? You see it. What will happen? Principal focus. Now we erase the previous diagram. This is C, and this is F. Now, the object is situated between C and F, that is between R and this is what will this? R, and this is F. Right? That is less than 2f. Less than 2f. 2f means R. Less than R or less than radius of curvature. Right? This is 2f. This is f. Now, the object is placed between C and F. This is the object OP. OP is the object. Now we show the ray diagrams. A light ray from the top point O of the object, which is situated vertically on the principal axis. A light ray is incident parallel to the principal axis on the concave mirror. Then after reflection, it passed through the principal focus. After reflection, it passed through the principal focus. And another ray which is incident, we extended it, M1, incident perpendicular, here O, A, B, D, at the point D. Since it is perpendicular at the surface of the concave mirror, it retraces its path, that is come back, and this will be the point of intersection of the two reflected rays. These two reflected rays meet at the point O dash. So O dash is the image, that is real image of the top point O of the object OP. Now we draw a perpendicular from O dash on the principal axis. This is the image of the object. Write it. A ray of light from O incident on the reflecting surface of the concave mirror at A. After reflection, it passes through the focus and another ray from O incident perpendicular to the reflecting surface of the mirror at D, hence it retraces its path and passing through the center of curvature. These two reflected rays meet at the point O dash. Hence O dash is the real image of O. If we draw a perpendicular O dash P on the principal axis, then O dash P will be the image of OP. Now, what will be the position of the image? The position of the image is that it is behind the center of curvature, that is greater than 2f. Greater than 2f. It is situated at a distance greater than 2 times the principal focal length, only focal length. And it is magnified. That is the size of the object, and size of the image if compared, then size of the image is greater than that of the size of the object. So, and this image is real and inverted, that is upside down. Now write this in your exercise book, that in this case, that is when the object is placed between the center of curvature and the principal focus, then the image will be formed at a distance greater than 2f or greater than r, that is behind, that is shifted from C, center of curvature, in a far away, and the image will be real, inverted, and its position, what will be this position? The position of the image will be at greater than 2f, that is greater than radius of curvature or 2 times the focal length, and the image is real and inverted and also magnified. Magnified means the image distance by object distance is greater than 1, right? Now we see what will happen if the object is placed at the focus, right? Object is focus, that is distance will be from the pole F, that is focal length. Points, you should mention the points. At first point, distance object is at infinity. Second point, object is behind C, that is center of curvature. Third point, when it is at C and that is center of curvature. And fourth point discussed earlier. These 4 points, the object is between the C and F. Now we 5 points. Point 5. The object is in which place? The object is at the placed or situated, placed at the principal focus. Then what will be the position, nature and magnification of the image? See, right? This is the mirror, concave mirror, M1, M2 we take here. This is the pole of the mirror, and this is C, that is center of curvature, and this is the principal axis. This is focus, just midpoint of CP. This is F. Object is situated at focus, that is OF. OF, or may write OQ, not OP. OP is are already denoted by P. Pole is denoted by P. So here, if a ray of light is incident from the top point O of the object OQ parallel to the principal axis, then after reflection it must passes through the focus. And another ray which falls perpendicular, right? Perpendicular, then it retraces its path because this ray is A, B, D at the perpendicularly fall. That is, it is incident perpendicular to the reflecting surface of the mirror at B, and hence it retraces its path. And these two reflected rays becomes parallel to each other. These two reflected rays become parallel to each other. Hence, they meet at infinite distance, at infinity, and hence the image will be highly magnified. In this case, we use the concave mirror as a magnification when we see in the case of microscope. Now, we see an object by magnified very large. That is, magnification will be obtained very large. Now, what will be the position of the image? The image will be situated at infinite distance, that is at infinite distance from the mirror. The image is obviously real and inverted. Inverted means upside down, and it is highly magnified. Remember this and write in your notebooks, exercise books, right? If the object is situated at the focus of a concave mirror, then the image will be formed at infinity. It is real and inverted, that is upside down, and it is highly magnified. That is, magnification is very, very greater than 1. Magnification is very, very greater than 1. That is, magnification, that is the image distance by object distance, ratio of image distance and object distance is very large. Now, we see the 6th point, the last point here. Last point, the 6th point. 6th point. The object is placed between pole and principal focus. Pole and principal focus, that is between pole and principal focus, that is less than focal length. That is less than focal length. That is less than f. F is denoted for the focal length. Now see, we draw a graph. We draw a ray diagram for the image formation by a concave mirror. Here it is a concave mirror. Concave mirror, pole, this is pole, this is center of curvature, this is the principal axis x prime, x prime is the principal axis, this is focus. We keep an object that is, or an object is located between P and F. This is the object. Object OQ. Object is taken as OQ. OQ. Now, a ray of light coming from O is incident on the concave mirror M1, M2 on its reflecting surface, parallel to the principal axis, that is parallel to the x prime. Then after reflection, it must passes through the focus. Through the focus. Through the focus. Through the focus. And another ray which is incident perpendicular to the reflecting surface of the mirror at C. Hence, after reflection, it retraces its path. If these two reflected rays, that is one C, A, B, D, E. These two reflected rays, here this is D, these two reflected rays are divergent, that is, they diverge from each other to each other, hence they cannot meet in front of the mirror. In front of the mirror, they only meet if we proceed the reflected rays backwards, that is behind the mirror. They meet at a point like this, right? O dash. Hence, O dash is the virtual image of the point O. If we draw perpendicular, and it is must be not a continuous line for showing virtual image. O dash, Q dash. Here, very important point, this point. We use this in various purposes. Doctors use this, and saving, as a saving glass we use this. Right? Now, if the object is placed between the pole and the principal focus, then after reflection from the mirror, they become divergent. That is, they are not meet in the front side of the mirror, but if we proceed these rays behind the mirror, they meet at a point O dash, and O dash is the virtual image. That is, these rays are appear to diverge from the point O dash, right? Hence, the image is formed what in the what position? The image is formed behind the mirror. The image is virtual, and the image is magnified. The image is magnified. That is, size of the object, size of the image is greater than that of the object, right? Write in your notebooks, exercise book, that in this case, that is, when the object is placed in between the pole and focus, then the image of the object formed by a concave mirror will be not real, will be virtual. Remember this. Virtual, magnified and obtained behind the mirror. Right? This we now learn the refraction of light in the next class.